Alright, with this guy, we're going to look for velocity and acceleration. Velocity and acceleration. Velocity is the first derivative. The acceleration is the second derivative. So we want to find the velocity and acceleration and describe the motion of the particle. So we need x prime of t, and then we need x double prime of t. So x prime of t is going to be 6t squared minus 14t. Oh, this should be t squared. This should be t squared. So minus 28t plus 22t plus 22. And then for our second derivative, then we're just taking the derivative of this, we're taking the derivative of the derivative, which is going to be 12t minus 28. Alright, so what's really important for us in order to describe the motion is to take these two pieces and set them equal to 0. So let's do that right now. 6t squared minus 28t plus 22 equals 0. We can factor out a 2. So 3t squared minus 14t plus 11. This will factor to 2 times 3t minus 11 and t plus 1, minus 1, minus 1. So when I solve, I get important values of my velocity. I get 11/3 and 1. These are big important values for my velocity. And when I do my acceleration, then 12t equals 28. So t equals 7/3. And then let's look at simple number lines on these guys. And we're interested in what goes on at 1 and what goes on at 11/3. And we're going to check the 3t minus 11, and we're going to check t minus 1. We don't need to check 2. The sign on 2 will always be positive no matter what, so we don't need to check him. And then for the acceleration, we're going to check 7/3. And just like the previous problem, if we wanted to factor this guy out, we could factor out a 4 from both pieces, which would give us 3t minus 7. And so again, I could just check the 3t minus 7. The 4 will never change signs. So when I pick a number less than 1, like 0, when I put 0 in, I get negative and negative, which is positive. When I pick a number between 1 and 11/3, pick something easy to work with, like say 2. And so when I put 2 in here, I get a minus and a plus, which gives us a negative. And then pick a number bigger than 11/3, like say 5. And when I do that, I get plus and plus, which gives me a positive. And then for the acceleration, pick 0, which gives us negative. Pick a number bigger than 7/3, like 5. That gives us a positive. So here's what's going on here. When we're asked to kind of describe the motion of the particle, here's the motion of the particle. Number 1, when we move from left to right, we notice that on our positives, the particle, anytime your derivative is positive, you're moving to the right. Anytime the derivative is negative, you're going to be moving to the left. So our particle moves to the right, It moves to the right from negative, well, we would say 0 in this case because we're talking about time, from 0 to 1. And then it also moves to the right from 11/3 to infinity. Okay. And then it moves left when we're negative. And where are we negative? From 1 to 11/3. So then we look at the acceleration, and on this guy, this just means we're slowing down. Our acceleration is slowing down. And on this side, our acceleration is speeding up. So when we're looking at this, we're accelerating. We're slowing down from 0 to 7/3. And from 7/3 to infinity, that should be open. We're speeding up. And so that's all there is to that guy. Don't let this be horribly challenging or hard. It's not. You're just looking at those derivatives and where they're equal to 0. All right, now we're going to use the f prime and f double prime to determine the graph of f. So when we do this, one thing we need to be aware of is if f prime at some point c is equal to 0 and f double prime at that same point is less than 0, then we have a max at that point at f of c. And then if f prime of c is equal to 0 and f double prime of c is greater than 0, then we have a minimum. Okay? And so those are kind of some things that we can look at when we are working these problems out. And so we've got the derivative f prime of x. So let's go through and find out what f double prime of x would be. And that would be 12x squared minus 24x. And then just make up we want to make up a sign chart with both the derivative and the second derivative. So if I set both of these guys equal to 0, and this guy 12x squared, so work them out. We can get rid of 4. We can divide 4 out or factor it out, however you want to do it. We'd have 4x squared times x minus 3. So on my number line, I'm going to be working with a 3 and a 0. And I'm going to be looking at 4x squared, and I'm going to be looking at x minus 3. With my second derivative, I can factor out a 12x, and that gets me x minus 2 equal to 0. And so when I look at this guy, I said 3 and wrote 0 here. When I look at this guy, I'm interested in 0 and 2. And we're going to check 12x and x minus 2. And so I've got one place that satisfies my derivative. And so we're going to really be interested with this 0 part, because 0 shows up on both. Okay? So let's look at some signs here. So when I take a number less than 0 and plug it into x squared, doesn't matter where I pick my number, I'll always get positive. When I pick a number less than 0 and work the bottom out, Then I get a sign chart that looks like this, which gives me negative, negative, positive. And then on the other side, I'm going to get a sign chart that looks like this. All right. So here's my two sign charts. So what's going on? Well, identify where the extrema of f occur. Well, extrema occur when my first derivative is equal to 0. So there's two places right here. Okay, I get extrema when x is equal to 0 and when x is equal to 3. So where does the extrema occur? When x equals 0 or 3. Okay. And that's not too bad. Find the intervals where f is increasing and the intervals where f is decreasing. So now I just look at my derivative, and I'm decreasing from from negative infinity to 0. Okay, I'm decreasing over here from negative infinity to 0. I'm also decreasing from 0 to 3. I'm only increasing on my derivative from 3 to infinity. So when I'm asked where we're decreasing from, we're decreasing in purple. And we're increasing in blue. All right. Find where the graph of f is concave up and where it's concave down. Well, now we go look at the second derivative. And we're really interested at what goes on around 0 and 2. So, I'm plus, which tells me I'm going to be concave this way. Then I'm minus, which is concave this way. And then I'm plus again, which is concave this way. So the question is, where are we concave up? Well, we're concave up from negative infinity to 0, and we're concave up from 2 to infinity. What about concave down? Well, we're concave down from 0 to 2. Okay, we're concave down from 0 to 2. And then it says to sketch a possible graph. Okay, sketch a possible graph. And so, again, sketching that possible graph, we want to use what we've got in our tables that we've learned here. So I have a maximum at where have I got? Let's see, I'm decreasing here, and increasing here. So I've got a minimum at 3. So over here at 3, I've got a minimum value. And do I have a maximum value? I don't think so, because I'm decreasing and I flatten out and I decrease again. So I've got something along the lines of decreasing and then decreasing again until I get to 3. But wait a second, at 0 I'm concave up and then I'm concave down. So I need to make sure that right here at 0 my concavity changes. It looks like it does. And then at 2 my concavity changes again, and it looks like it does, from negative to positive. So I would have a graph that could look like this. It doesn't have to look like this, but this would just be a possibility for what's going on. So again, you just practice drawing these things, and the more you draw them out, the easier it will get to work through them.